Hello, everybody. My name is Eden at the Great Valley Museum located at the Modesta Junior College. Welcome to Astronomy with Fred. Fred, you're talking about the Big Dipper today. And from what I understand, the Big Dipper has many different uses. What are some of the different ways that the Big Dipper can be used?
Yes, Eden, I can show you right here different ways in which the Big Dipper can be used. It can be used as a celestial compass, a clock, a calendar. It can also be used as a ruler for the night sky measurements. All right, when you look outside at night and it's starting to get dark, you start to focus on the Big Dipper right here. You'll notice during this time of year, which is the spring/summer time, it's up very high in the night sky. As the months go by, when it gets towards the summer and you're walking out after sunset, you'll notice during the summer, the Big Dipper will be at this position right here and relative to the North Star. As we move 3 months later, you'll notice during the fall time that the Big Dipper is very low to the horizon. Here's the horizon right here. And that will be basically showing the season fall in the night sky. 3 months later, you walk outside after sunset, you'll notice the Big Dipper will be on the right-hand side of Polaris right there. So as you can see, the Big Dipper not only can be used as a compass, but also a calendar in the night sky. As you know, the Earth takes about 24 hours to make one complete rotation. Keep that thought in mind when you look at this here. Once again, here's Polaris, here's the Big Dipper, here's Cassiopeia. As the night sky progresses, the Earth is rotating, and so our stars are going to be going around in a counterclockwise position. And you can use this as a clock. For example, let's say right here it's 9 o'clock, and we go over here. We know that 3 hours have gone by, and that's because in these quadrants here, we have 4 different quadrants here. Think about what's 24 divided by 4. You get 6 hours in each quadrant here. So if the star lined up right here with Polaris, you're looking about 3 hours into the night. This was at 9 o'clock. This would be at midnight, and this would be 3 in the morning. And you can do that throughout the night. You can say that, okay, that's like 6 in the morning. And this would be 9, of course, 9 in the daytime. You won't see the Big Dipper because too much light. But you can use the Big Dipper in the night sky as a clock. All right, so here's a really neat thing about the ruler part of the Big Dipper. You can use the Big Dipper as a template for a hand ruler. For example, the star, the 2 stars right here, the actual pointer stars, are about 5 degrees. So if you use your hand, that'd be like 3 fingers like this, okay? Now the distance between the 2 stars here on the Big Dipper, the bowl part, that's about 10 degrees. That'd be a fist. That's about 10 degrees right there. And of course, when you're doing this, you extend the arm fully. Now the distance between this star, the pointer star, and this first one on this set of 3 stars there would be 15 degrees. You tuck in these fingers here and hold out the little finger and the index finger. That distance between there would be about 15 degrees. And then if you take the Big Dipper's pointer star again, all the way to the tail star right there, that would be 25 degrees. And there you put the 3 fingers down and use your thumb and your little finger like that. And that would be the distance between here would be about 25 degrees. Okay, so Ian, we live in the about 37 degrees north latitude, all right, above the equator in the northern hemisphere. And so you're asked to find the North Star. So it's about 40 degrees above the horizon. So take your fist out at the horizon, okay, and then stack it with another one. That'd be 20. The next would be 30, and then 40, and then point with the last one there. And that is approximately right where the North Star would be, facing north. If you happen to be in like Hawaii or in the southern, like 17 degrees, you would be right about here, close to the equator. If you're like in Alaska, it'd be right above you. Okay, so it all depends on where you're at. It dictates the latitude. A great way to find your way about navigation wise, the latitude, where you're on this planet.
Fred, you mentioned asterisms. What's the difference between asterisms and constellations?
There are 88 constellations in the night sky. And asterisms are actually some of the patterns and shapes that you see within the constellations. And constellations are usually mythical beasts, hunters, other famous people that derive from the Greek mythology. Right here at the table, I have some examples. Take a look at these again, the Big Dipper here in Cassiopeia and also Polaris. As I rotate this around, they're always visible in the night sky, whereas the other constellations will come and go throughout the year. Okay, our first asterism would be right here on Ursa Major, the Great Bear. I remove this here. You can see the asterism right here. Looks like the Big Dipper, or some people call it the plow or the wagon, but that is an asterism right there. It's a shape within the constellation. And you'll see this every single night going around the North Star, whereas the other constellations I'm going to show you come and go throughout the year. All right, this is the constellation Leo right here. The asterism in this one would be the sickle shape right here. You'll see the blue star right there. That's a heart of Leo. That's the asterism. That's the constellation Leo. You'll find Leo in the spring. This right here is Sagittarius, and here inside you have an asterism, looks like a teapot. Here's the handle right here. Here's the top of the teapot and the spout right here. You'll find Sagittarius in the summer. So right here we have the constellation Scorpio or Scorpius. Right in the center there you have actually the red star Antares, and there's a right here, this right here looks like a hook, and that would be like the asterism in this constellation right there, a fishing hook. You'll find Scorpius or Scorpio in the summer. All right, this constellation is Pegasus. Normally you'll see it like this in the night sky, but the asterism is right here, these four stars that make up the square. It's called the Great Square of Pegasus, and that's the constellation Pegasus. You'll find Pegasus during the fall. All right, here are three different constellations that make up this asterism called the Summer Triangle. This over here is actually a swan, and this over here is a harp, and this one over here is actually an eagle. And these three make this triangle, and that's an asterism. You'll find the Summer Triangle in the summer. Okay, this is actually Orion, the Great Hunter, and this is in the winter time that you see this. There really is no asterism here, unless you want to call that belt an asterism there. This right here is a red star Betelgeuse. This is Rigel, the blue star here, and this is the constellation Orion. You'll find Orion in the winter.
Oh, I didn't know there was a red star and a blue star in a constellation. What makes the stars red and blue?
Yes, there are different color stars out there in the night sky, and not just the red and blue, but there are like white stars and yellow stars. Let me show you, and I will need you to switch with me. So I use a candle to represent the different colors of stars in the night sky. For example, your hottest flame is down at the base. It's got a bluish color to it. Just remember that. As you progress up the flame, it gets kind of a white to orange look. And then at the very top, you get this kind of a reddish color. That's showing the different temperatures of that flame. Well, keep that in mind as you're looking at the night sky. If you see a blue star, then you're looking at a relatively new star. It's very hot, up to 90,000 degrees Fahrenheit, at least that hot. And as it gets older, it starts to turn color to more of a yellow, more mature color. And this star is a lot cooler than the blue star. And then as it cools even more, it then will progress to this color, the one that you noticed in the night sky, a red star. And so when you look at these different colors, you're looking at temperatures of the different stars, and you're also looking at the age. So it kind of you learn two things about the stars. When you look at the color, you can figure out the age and also what the temperature is like.
Speaking of stars, how come some stars are brighter than others?
Hopefully with these flashlights, I can answer your question. All right. Here we have one flashlight that's very bright, okay? And we have one here that represents a very dim star. Now, it could be that the two are right next to each other like this in the same plane, and this one's more massive than this star here, has much more energy it's projecting. Or it could be a situation where this star is further back from Earth, where it still makes it look like this bright and this dimmer because of distance. Now, in just a minute, I'm going to show you how we can mathematically figure out the distance of a star. All right, here's the sun right here. Here's the Earth in two different positions here. As the Earth goes around the sun, there's 6 months. Here's 6 months right here. Over here are these lines that are making this little triangle right here. And this is the parallax angle. Astronomers look at the sky on a specific date and then 6 months later to see how far or nearby the star appears to move relative to the background. So if you're over here, here's the background stars, the distant stars here. When you're over here, the distance of the background stars are right there. There's this much of a movement in the arc. And the angle these astronomers measured to the star to move is actually the same angle they would see the Earth move if they could travel to the star. Because the scientists know the distance the Earth has traveled in 6 months, which is twice the distance to the sun, they have all the information they need to find the distance of the star. And here you can see the parallax angle here and the angle here and the movement of the stars as we go around the sun. You can see those stars actually in different position.
Thank you, Fred, for the great information on constellations, asterisms, the Big Dipper, and the different type of stars. And thank you for joining me today for Astronomy with Fred. But wait, stick around for the bonus activity.
Here is the way you can make your very own constellation viewer. You will need for this activity a flashlight, a cardboard or plastic tube, a printout of your favorite constellation, cardboard, pencil, pair of scissors, and tape. All right, the first step, you need to cut out your constellations, scissors, and your picture of your favorite constellation. Next, take a sharp pencil and poke holes where the stars are at in your constellation. Use cardboard below so it doesn't poke a hole through the table. All right, next tape to the tube, your constellation, using just this kind of tape. Okay, when you're done, you can take your flashlight and you can shine it through there and it can make like a star projector on the ceiling. Or you can make it as a constellation viewer where you look up in the ceiling where the lights are at, but make sure you don't do this outside in the sun. And you can see the actual constellation.